Welcome back to The Explainer. Okay, have you ever looked at a massive industrial plant? You know, those towering metal cities with the endless mazes of pipes, smokestacks, and massive steel vessels. From the outside, it honestly looks like pure chaos. But it's actually a mind-blowing symphony of precision engineering. Today, we're diving straight into the very first and, I'd argue, the absolute most crucial step of building these megastructures. We are talking about the equipment drawing check. It is quite literally the blueprint to reality, and I'm going to show you exactly how construction engineers make sure these 1,000-ton behemoths get installed flawlessly. To really wrap our heads around the complexity here, let's look at a pretty relatable analogy. Imagine you're opening a brand new location for a global franchise pizza kitchen. You've got the funding, you secure the perfect location, and you've got the official franchise guidebook. So you go ahead and order the top-of-the-line massive commercial pizza oven. Well, buying it is the easy part. The real nightmare starts the second that delivery truck pulls up. You have to start asking, does it actually fit through the front doors? Can the kitchen floor even support its weight? Does the exhaust port perfectly align with the ventilation duct you already installed in the ceiling? Building a megaplant is exactly like this, but instead of a pizza oven, you're trying to install a 1,000-ton industrial chemical vessel. And that brilliantly highlights the stakes we're dealing with. Think about it. What happens if the blueprint for that massive pizza oven, or in our case, an industrial vessel, is just 1 millimeter off? Well, best case scenario, the oven doesn't fit through the door. Worst case, you force it inside and the floor completely collapses under the unexpected weight. Or the exhaust doesn't align and you can't even safely turn the kitchen on. In plant construction, a single millimeter or a slightly miscalculated weight can lead to catastrophic delays, literally multi-million-dollar damages, and incredibly severe safety hazards. The engineering drawing isn't just a guide, it is the absolute source of truth. So, here's our roadmap for today's explainer. First, we'll establish the golden rule of plant construction. Then, we'll break down the drawing check into 3 main pillars: version control, dimensions and weight, and finally, accessories and internals. Let's get right into it. Starting with the golden rule, preparation is 90% of the work. Before a single massive crane is ever fired up or a single hard hat is even put on at the site, there is an overarching philosophy that every single construction engineer lives and breathes by. Preparation is 90% of the work. You see, if the preparatory paperwork is flawless, the actual physical lifting and installation of the equipment is, well, it's actually pretty straightforward. You basically just let the specialized subcontractors do their physical work while you verify it matches the instructions. The real heavy lifting, that's done at a desk, meticulously verifying those drawings. So what exactly are we preparing and checking? Whenever an engineer gets an equipment drawing, they have to systematically check 3 specific pillars. You can't just glance at it and say, looks good. You need a highly structured approach. You verify the version of the drawing, you calculate the logistics of its size and weight, and you audit every single accessory and internal component. Let's break these down one by one. Pillar 1 is version control, securing the latest drawing. Now, I know this might sound like basic administrative work, but in plant construction, securing the absolutely most recent blueprint is a matter of life and death for a project. Notice the technology mentioned here, an EDMS, or Electronic Document Management System. Why do we go through the trouble of using this? Because drawings change constantly. We're talking about multi-year projects where the piping team might suddenly realize they need to shift a connection point to avoid hitting a structural steel beam. Or the vendor might update the drawing to reflect a slight change in how they welded a seam. If these revisions aren't rigidly tracked electronically, absolute chaos ensues. So the absolutely crucial point here is this. Working off an outdated or old version drawing causes massive, incredibly costly errors. Think about it. If an engineer accidentally issues a revision from, say, 3 months ago to the construction crew, they might pour a huge concrete foundation with the massive anchor bolts set in completely the wrong places. When the machine finally arrives on site, it literally won't bolt into the ground. The blame for this kind of baseline error is severe. Securing the latest drawing is step 0, always. All right, let's move on to pillar 2, dimensions and weight. Once we know for sure we have the correct, updated paper in our hands, we shift our focus to the physical reality of the equipment itself. Long before a piece of equipment is ever lifted by a crane, it has to physically travel from the vendor's shop, the factory where it was built, all the way to our construction site. Sometimes this involves crossing entire oceans, driving down narrow public highways, and navigating a super crowded construction site. By meticulously checking the exact dimensions on the drawing, engineers make sure the equipment can actually clear highway bridges, power lines, and existing pipe racks without crashing into anything. Now let's look at this weight table, because this is a huge trap that catches a lot of beginners. The weight of this vessel during erection, which means when it's empty and being installed, is around 140,000 kilograms. But look at the column on the far right, full of water. It skyrockets to over 1.2 million kilograms. Why in the world would it be full of water? Well, before a plant goes live, equipment is completely filled with water for what's called a hydrostatic test. We do this to check for leaks under massive pressure. And as a quick fun fact, we use water because it's incompressible, meaning if a vessel accidentally bursts during testing, the water just drops harmlessly to the ground. If you use compressed air, it would literally explode like a bomb. Anyway, if you only looked at the empty weight on the drawing, you might design a concrete foundation that instantly crushes into dust under the massive weight of that testing water. And the weight doesn't just dictate how strong the concrete foundation needs to be, it dictates the cranes. Once the true maximum weight is verified on the drawing, engineers formulate a rigging plan. This is a highly complex engineering calculation that determines exactly what capacity crane is needed, exactly where the center of gravity is, and the strict safety margins required to pull off the lift. You absolutely cannot guess this stuff. The blueprint gives you the raw data, and the rigging plan turns that data into a safe physical reality. And that brings us to Pillar 3. Accessories and internals. Okay, so we've checked the main body of the equipment, but as always, the devil is in the details. An industrial vessel is never just a smooth, empty steel tube. It's totally covered in accessories that have to be verified on the drawing. We are talking about external ladders, platforms for the maintenance workers to stand on, delicate measuring instruments, and nozzles. The construction engineer has to look at the drawing and ask, are these going to arrive completely pre-attached from the vendor, or are they shipping loose in a wooden box, meaning my crews need to assemble them piece by piece out in the field? Knowing this changes your entire installation schedule and budget. I actually want to pause right here for the beginners and clearly define what a nozzle is, because you are going to hear this term constantly in plant engineering. A nozzle in an industrial plant isn't like a little garden hose nozzle. It is a critical, heavy-duty, flanged connection point that sticks out of the side of a vessel. It is literally the exact spot where the plant's piping network is bolted onto the equipment to allow liquids or gases to enter or exit. If the drawing has the nozzle in the wrong place, or angled even a few degrees off, the entire piping network of the plant simply won't connect. Now here is a really fascinating logistical reality about the journey of these massive machines. Picture a towering vertical chemical reactor. When it's operating in the plant, it stands completely upright. But to ship it across the ocean on a cargo vessel, it has to be laid totally flat on its side, sometimes for weeks or even months. Gravity is constantly working against it in this horizontal position, and the heavy internal components inside the vessel can violently shift, warp, or even snap during rough transport on the high seas. So, to prevent this internal damage, vendors install temporary transport fixings. These are heavy metal brackets and structural supports welded inside the machine to hold all those delicate internals completely rigid during the horizontal journey. Now, usually, the vendor will paint these temporary fixings a bright, glaring yellow or red so you don't miss them. But here is the critical warning. The construction engineer must explicitly note these on the drawing and ensure their crews remove them once the machine is safely standing upright on site. It happens more often than you think. People forget to remove these temporary shipping braces. And if you forget and you fire the plant up, you will instantly tear apart and destroy the internal workings of the equipment. It's a tiny, tiny detail on the drawing that can literally save or ruin a billion-dollar facility. Wrapping things up with our conclusion, the blueprint to reality. We've seen today how checking an equipment drawing isn't just glancing at a pretty picture. It's a rigorous, intense process of strict version control, logistical weight planning, and truly microscopic attention to detail. That piece of paper directly dictates the success or failure of the physical construction. So I want to leave you with this provocative thought. In the massive scale of plant construction, an entire 1,000-ton operation, millions of dollars, and the safety of hundreds of hardworking people all hinge on the meticulous checking of a single piece of paper. The prep work is literally everything. So think about your own life, your own business, or your own goals. How well are you checking the blueprints of your own projects before you start lifting the heavy weights? Thank you so much for joining me on this explainer. Keep learning, stay focused, and I'll catch you on the next one.